Hello students, today we are going to learn how to use algebraic identities. The famous algebraic identities which you have been introduced to in class 7 and 8 are a plus b whole square, a minus b whole square and a square minus b square. You know that a plus b whole square is a square plus b square plus 2ab and a minus b whole square is a square plus b square minus 2ab. A square minus b square, we can write it as a plus b into a minus b. Now there are some identities which can be derived with the help of the first two. For example, let's say you want to find a square plus b square. So that will be obtained by adding these two. So it will be a plus b whole square plus a minus b whole square by 2. Now suppose you subtract these two identities. So you will get 4ab is equal to a plus b whole square minus a minus b whole square. So by adding these two, we are getting this result, and by subtracting them, we are getting this result. So we can find a square plus b square and ab in this manner. So these are the famous identities and their applications. There are a lot of situations where these identities can be used in different ways. For example, we can write a plus 1 by a whole square like this. We can write a minus 1 by a whole square like this. So once we know these two, we can write a square plus 1 by a square is equal to a plus 1 by a whole square plus a minus 1 by a whole square by 2. And you can see that the pattern is similar. Just like a plus b whole square, you have a plus 1 by a whole square. Like a minus b whole square, you have a minus 1 by a whole square. And just like a square plus b square, you have a square plus 1 by a square. Similarly, you could also have a square minus 1 by a square is a plus 1 by a into a minus 1 by a. Moving on to the cubic identities, a cube plus b cube can be written in two ways. It is either you can say a plus b into a square minus ab plus b square, or the other option is you can write it like this: a plus b whole cube minus 3ab into a plus b. So a cube plus b cube has got two expressions. One is this and the other is this. Depending on the question, you'll have to decide which one has better usage. Similarly, a cube minus b cube can be written as either a minus b into a square plus ab plus b square, or you can write a minus b whole cube plus 3ab into a minus b. So once again, there are two expressions, and depending on the usage, we can choose any one of them. Now there is a very famous identity, a cube plus b cube plus c cube minus 3abc. This is a very, very well-known identity, and its value is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. So this is the value of this expression. Now what we can do is we can keep the a plus b plus c as it is, and keep a half outside, and this entire term inside the bracket can be written in another way like this. So the entire term inside this bracket can be written like this. Put a half outside, a minus b whole square plus b minus c whole square plus c minus a whole square. Now this particular identity which I wrote, it has got two very major uses. The first use is, if you are ever told that in a question, if you are ever told that a plus b plus c is 0, then without deliberation you can say that a cube plus b cube plus c cube is equal to 3abc. Once again, if you in a particular question, if you are told that a plus b plus c is 0, so you just put a plus b plus c is 0, you will find that a cube plus b cube plus c cube is equal to 3abc. This has got lot of applications. The other thing is that suppose you are told in a particular question that a square plus b square plus c square minus ab minus bc minus ac is 0. Let's say you are told in a question that a square plus b square plus c square minus ab minus bc minus ac is 0. So you can easily conclude that a, b, c have to be equal to each other. How? I told you a while ago that a square plus b square plus c square minus ab minus bc minus ac can also be written like this. Half into a minus b whole square plus b minus c whole square plus c minus a whole square. And if this entire expression is 0, it means that the sum of these three squares is 0. So that is only possible if a is equal to b is equal to c. So this particular identity, a cube plus b cube plus c cube minus 3abc, has great usage in many areas of algebra. And these are the special two applications of this particular identity. There is another identity which is not used that often, but it is also an important identity, that is a plus b plus c whole cube. So a plus b plus c whole cube this is a very important identity in certain very rare questions which cannot be solved very easily by using the binomial cubic expansion. This particular trinomial cubic expansion has got tremendous usage, and you can see that it has a very nice symmetry about it. A plus b plus c whole cube is a cube plus b cube plus c cube plus 3 into a plus b into b plus c into c plus a. Now there are some general identities which are very rarely used, but I would advise the students to take note of these. First of all, a to the power n plus b to the power n. Suppose n is an odd integer, suppose n is an odd natural number, then a to the power n plus b to the power n can be written as a plus b, and subsequently you write the remaining terms like this: a to the power n minus 1 minus a to the power n minus 2b dot dot dot, and the last one is b to the power n minus 1. So this is if n is odd. So let's take an example. Suppose n is 3, then we have the very well known identity which we have used um, just a little while ago. So if you have n is equal to 3, then this becomes the very well known a cube plus b cube identity. Secondly, a to the power n plus b a to the power n minus b to the power n, if n is even, it can be written like this: a plus b into a to the power n minus 1 minus a to the power n minus 2 into b up to b to the power n minus 1. So let's have a usage of this identity. Suppose a to the power 4 minus b to the power 4. So we can write it as a plus b into a cube minus a square b plus ab square minus b cube. So this is a very important identity if n is even. Now there is a third identity, a to the power n minus b to the power n is a minus b into a to the power n minus 1 plus a to the power n minus 2b up to b to the power n minus 1. Now this identity is applicable whether n is even or odd, it doesn't matter. N may be even or odd, it doesn't matter, you can use this identity. So let's see a couple of examples of this third one. First of all, if you have a cube minus b cube, then it is a minus b into a square plus ab plus b square. And if you have a to the power 4 minus b to the power 4, then you have a minus b into a cube plus a square b plus ab square plus b cube. So this is a very important third identity because it is applicable both when n is even as well as when n is odd. So that brings us to an end of this very interesting session of how to use algebraic identities.